Hello everyone, welcome back to the Geotechnical Academy channel. In this lesson I'm going to explain the tutorial number 2 from Plaxis manual, Plaxis 3D Connect edition. As you see, this figure illustrates top view of the soil contour and excavation pit. The soil geometry is 50 meter wide and 80 meter long, and the excavation pit is located in here with these coordinates, and it is 12 meter wide and 20 meter long. To prevent the soil collapse, first the sheet pile walls are installed around the proposed excavation pit, and to decrease the lateral soil pressure on the sheet pile walls, the wallings are installed to the sheet pile walls 1 meter below the excavation. And in the middle of the excavation pit, 3 struts are installed, and 2 ground anchors are used each side of the excavation pit. Also in this side near the excavation there are a distributed surface slot, and the excavation depth is 6.5 meter. And this figure shows the cross section of the excavation pit with soil layers. As we see, there are 4 soil layers which consist of fill, sand, soft clay and sand. To decrease the time of the video, I already defined all the materials, soil materials and materials for the structural elements, so I'm not going to define the materials in this lesson. You can watch my previous videos if you want to know how to define the materials. And these are the materials for the soil layers, which are 3 materials for fill, sand and soft clay. Also these are the materials properties for the beam, for strut and walling, and also for ground anchor for the nut to nut anchor part. Then the ground anchor is composed of 2 parts: grouted part, grouted body, and nut to nut anchor. And these material properties will define for the grout body. Also, these are the materials for the sheet pile walls. So in here I will explain the example step by step and in easy way. Okay, we start modeling our example. I go to Plaxis and start new project, tutorial number 2, excavation in sand. And the soil contour, as in our example, x maximum is 80 meters and y maximum is 50 meters. 80 meters and y maximum is 50 meters. Okay, I defined the soil contours. So now we'll define the boreholes and define the soil layers. I click create boreholes, click in here in the origin 0, 0, 0 coordinates. Okay, and I will add 4 layers, 1, 2, 3, 4, and it starts from 0 to -1, and from -1 to -9.5 meters, and from -9.5 to -11, and from -11 to -20. And the waterhead is located at -4 meters. So I type -4, and I go to materials. As I said, I already defined the materials for this example, which are fill, sand and soft clay. So I assign the materials. In the first layer we have the fill, in the second layer we have the sand, in the third layer we have the soft clay, and in the last layer we again have the sand. Okay, now I finished defining the soil contours and soil layers. Then I go to structures. So first we will create the surface for excavation volume with these coordinates. I go to create surface, just create a surface, and in here I can change the coordinates, which are 30, 20, 0, and 30, 32, 0. The next is 50, 32, 0. And 50, 20, 0. Okay. Now I finished creating the surface for the excavation volume. Now I have to extrude this surface to z equal -1. This will be the first excavation, and after that we will install the wallings and struts. After that we will excavate to z equal -6.5, and to define the sheet pile walls we will also extrude this surface to -11, and after that we will decompose this surface. Okay, I click the surface, extrude to first to -1, again to -6.5, again to -11. Okay, then we decompose the surface between z equals 0 to z equal -11, and after that we delete the top two surfaces. I click this excavation volume and right click, decompose into surfaces, and after that I click the top surface, delete, and again click the top surface and delete. Okay, so then we will hide the excavation volumes in the model explorer from z equals 0 to -1 and z equal -1 to -6.5. So I click this excavation volume and right click, hide, again hide, also hide. Now we will create beams or wallings around the excavation at elevation z equal -1. So I go to create line, create beam, and click in here, press shift and go down -1. Now I will create the beam around the excavation. Then I will create the straits with these coordinates. Create beam. Okay, then I click the straight and go to array commands, in Z direction, number of column equal 3, and the distance between columns in X direction equal 5 meters. Okay, I finished modeling the wallings and struts. Now I will define the materials for these structural elements and assign the materials to them. So I go to material and I will go to beams. As I said, I already defined the materials, so I will assign the wallings just by dragging and dropping, and this material for strut. Okay, I finish this also. After that we have ground anchors, and the ground anchors is composed of two parts. The first part is going to be modeled by node-to-node anchor, and the second part is going to be modeled by embedded beam. So these are the coordinates of the node-to-node anchor. I will go to create a line, node-to-node anchor, just make it, and in here we can change the coordinates 30, 24, minus 1, 24, minus 1, and the second coordinate is 21, 24, minus 7, 21, 24, minus 7. I model the first node-to-node anchor, and we have another node-to-node anchor in this side also, and I will again change the coordinates, which are 50, 24, minus 7, which are 52, which are 50, 24, these are minus 1, not minus 7, sorry, 50, 24, minus 1, 50, 24, minus 1, and the second coordinates is 59, 24, minus 7, 59, 24, minus 7. Then I will create the grafted part, which is going to be modeled by embedded beam. So I go to create line, embedded beam, in here like that, and in here I will change the coordinates. The first one is 21, 24, minus 7, 21, 24, minus 7, and 18, 24, minus 9, 18, 24, minus 9. And in the other side we also have the grouted body, and again change the coordinates, which are 59, 24, minus 7, and the next coordinate is 62, 24, minus 9. So I finished modeling the ground anchors. So after that we will define the materials for these ground anchors, embedded node-to-node and grouted body. So I go to materials and I go to embedded beams. This is the grout body, like that, and like that. Also the node to node anchor, like that, and I assign to this also. Okay, so now I'll select all the ground anchors and go to array option, shape in 1 dimension in Y direction and 2, and the distance between the columns is 4 meters. Okay, so after that we will make all the ground anchors to one group. So I will select all the ground anchors. So right click, group. So in here the group is created. So we will change the name to ground anchors. This helps us to be easy to activate or deactivate these ground anchors in any construction stage. So the next step, we will define the sheet pile walls. So we will select all the surfaces from z equal 0 to -11 and right click, create plate. So after that we will define the materials for the sheet pile and assign it. As I said, I already prepared the materials for the sheet pile wall, so I assign the material to the sheet pile wall to the place like that, and again select all the sheet pile wall and assign negative and positive interfaces. Okay, so I finished modeling all the structural elements. In here we have something which is non-isotropic, different stiffness in 2 directions sheet pile walls are defined in this example. So the local axis should point in the correct direction, which defines which is the stiff or the soft direction, as the vertical direction is generally the stiffest direction in the sheet pile walls. Local axis 1 shall in the z direction. So this figure shows the local directions for the plate in the Plaxis. As we see, this is the 1 direction and 2 direction and 3 direction. So what should we do now? We should select each wall and change axis function to manual in the selection explorer and set axis 1z equal to -1. So I select this one, and so I change axis function from automatic to manual and type axis 1 z equal to -1. Same thing for all the plate. Okay, as we say, there are a surface load near the excavation, so I will go to create surface and make a surface with an arbitrary coordinates, and then I can change the coordinates. The coordinates of the surface load is 34, 19, 0. Thirty-four, 19, 0 and 41, 19, 0. Next is 41, 12, 0. 41, 12, 0, and the last one is 34, 12, 0. Okay, I also finished creating the surface for the surface load, so I will click this surface and create surface load. Okay, so we finished everything. Now we go to mesh. Now we go to mesh and create mesh. In this example we will use the medium mesh. Okay, so after that I go to staged construction. So in this example we will have 6 staged constructions including the initial phase. So in the initial phase the K0 is used and all soil volumes should be active and all structural elements should be inactive, like that. So this is the initial phase. We will use the default value K0 procedure, and all the soil volumes are active and all the structural elements are inactive. So I add the next phase, and in this phase we will install the sheet pile walls and excavate the soil volume from 0 to -1. So first I will activate all the plates and click on the soil volumes and right click deactivate. So I will add the next phase, and in this and in phase 2 the wallings and struts will be installed, so we will activate all the beams. In phase 3 install ground anchors, activate ground anchors, so we will add another phase, and in this phase we will go to group and activate all the ground anchors, and in the model explorer apply a pre-stressed force of 200 kN for each node-to-node anchor. So in here I go to node-to-node anchors and expand node-to-node anchor 1 and adjust pre-stress 200 kN. So I will apply this one for each node-to-node anchors. Next, node-to-node anchor 3, 200 kN, and the last one Okay, I finished with this one also. So in phase 4, select soil volumes to be excavated from z equal -1 to -6.5 meters and apply dry condition and excavate or deactivate the soil volume. So I add phase 4 and select this soil volume and change the water condition from global level to dry and right click deactivate the soil. So after that it says hide the soil and wall around the excavation. So just select and hide. And hide these sheet pile walls also. So we will select the soil below excavation z equal -6.5 to z equal -0.95, and we will apply the water condition to hit z equal to -6.5. So I will select this soil below the excavation and change water condition to head and z equal to -6.5. And for the soft clay below the excavation, we will apply the water condition to interpolate. Okay, if you want to see the steady water pressure, you can just click in this button, preview this phase. So I will not doing this, and I will continue to go to phase 5 and activate the surface load. So I will add the next phase. I will display all the geometry again, and in the phase 5, so we forget something. So in the phase 2, plates and interfaces should be active. So after phase 2, in each phase, all interfaces should be active, and in the phase 5 also. So in the phase 5 we will activate the surface load, and the amount of the surface load is -20 kilonewton per square meter. -20 kilonewton per square meter in the z direction. So now everything is finished. As we said, in the first phase, we will the sheet pile walls should be installed. So we activate the plates and interfaces. In the phase 2, all beams, wallings, and struts were activated. In phase 4, the next excavation volume was excavated from z equal -1 to -6.5. In the phase 5, we activate the surface load. So now the example is ready for calculation, but before starting the calculation, we will select some stress points next to the excavation pit and loadings to plot the stress strain curves for these points later on. So the points are like that. These are the points. I will select point for curves. So the points is 37.5, 19 and z equal minus 1.5. I will select the nearest stress point to this coordinates. So next we have minus 5, then we have minus 6, and then we have z equal to minus 7. Okay, I select the 4 points, I click update. Now the example is ready for calculation, so I start the calculation. Okay, the calculation is finished, and we don't have any error, so everything is okay. Now I can go to results. So in the results I can check the deformation in the x direction. So in the x direction the maximum deformation is 12 millimeters. So in the y direction the maximum is 20 millimeters, it's about 2 centimeters, and the maximum displacement in the z direction is about 18, about 2 centimeters. So if also I can see the forces in the structural elements like sheet pile walls, beams, or ground anchors. So to see the forces in the sheet pile walls, I click in here, select structures, and press Ctrl and Shift and double click on the sheet pile walls. So I can go to forces and see the normal force or shear forces or moments in the sheet pile walls. So this is very helpful. So this is very helpful for a geotechnical engineer, and I can also see the forces in the beams like that. I again click on the structure element and press Ctrl and Shift and double click on the structure members. If I go to force, moment, so I can check the moments in all the direction, or the most important force for struts in this example is the normal force, like that. So the maximum normal force is equal minus 445 kilonewton. Also now we will plot stress strain curves for the points next to the excavation pit. I go to curve manager, new, and select the first point in x and y direction. So in the x direction I will select the total strain, and in the y direction I will select the stress and principal effective stress and stress 1. Okay. So if I want to add the other point, right click and add curve from current projects. So we'll just change the points. Okay, and the next point. The last point. Okay, so from this plot we can examine the maximum strain and maximum stress in that point. So this example is finished, and please do not forget to like, share and subscribe to our channel to get more future videos. Thank you.